Hi there, this is Prathamesh, and in this session, we'll learn more about cash. Before we try to understand what cash is, let's try to understand how a coffee shop works. Let's assume our friend Bob has started a new coffee shop. Let's assume Bob was so busy building his shop that he forgot to install a price board that would have helped people learn about the price of different types of coffee that his shop sells. Customers arrive at the shop and frequently ask for the price of different types of coffee. Bob doesn't remember the price and he frequently checks his laptop to see what the price is, and this adds a lot of delay. Customers realize it takes too long for Bob to respond and they start heading to a different shop. What can Bob do to solve this problem? You guessed it right. Bob can now install a board on the top of his shop that would help customers understand the different types of coffee that is served at his shop and the corresponding prices of each type of coffee. Bob installs the board and his customers are now happy. Thus, Bob has minimized the delay and now can process the order at a faster pace. In theory, Bob has cached the price of coffee. Price of coffee was a frequently requested information and Bob has managed to put it on a board and made it easy for customers to access, thereby minimizing the delay and improving the performance of his shop. Thus, cache is actually a hardware or a software that can store data that is either frequently requested or needs a lot of computation power and time. Cache works on the locality of reference principle. Frequently requested data is likely to be requested again, hence, it makes sense to store this data in cache since the cache is faster compared to hard disk. Now that you know what cache is, let's try to understand how a computer works. Let's say your computer CPU is trying to access data from hard disk. CPU typically has a higher speed, somewhere in the range of 1.8 to 4 GHz. Your hard disk, on the other hand, is slow and typically runs at 5 to 10,000 RPM. Now, even though you have a CPU that is fast, your hard disk is still slow, and hence, any data that needs to be extracted from the hard disk will take a huge amount of time. How can we solve this problem? You guessed it right. How about we add a cache or RAM? Let's say you added RAM. RAM runs at a speed of 1.6 to 3.2 GHz. Now you can store the data frequently requested by CPU in the RAM. And now CPU can access this data with minimal delay. Wait a minute. These days, CPUs include a lot of cores. Now each CPU will need a certain amount of RAM to access this data. How do we solve this problem? Let's say we have a quad-core CPU. We can solve this problem by adding a static RAM, also known as CPU cache. The CPU cache is further classified as L1 cache, L2 cache, and L3 cache. You will need to remember that the speed of L1 cache is higher than the speed of L2 cache. The speed of L2 cache is higher than the speed of L3 cache. The speed of L3 cache is higher than the dynamic RAM or DRAM, and the speed of dynamic RAM is higher than the hard disk. Also, the cost of dynamic RAM is lower than the cost of static RAM, but the speed of static RAM is higher than the speed of dynamic RAM. Simple reason for this behavior is that dynamic RAM includes capacitors and capacitors leak charge, so they need to be frequently recharged, whereas static RAM is made up of pure transistors, which are much more efficient than capacitors, and hence static RAM is faster than dynamic RAM. Now that you have learned what CPU cache is, let's try to understand what application cache is in the context of system design. Let's say you have three users, user A, B, and C, and all these users are trying to use an e-commerce app. Let's assume this e-commerce app is hosted on this app server. Let's assume all these three users are trying to access the price of a popular electronic device that's available on this e-commerce app. Let's say this price is actually stored in their database server. Every time a user makes a request for this price, the request is relayed to the database server and the response is sent back to the user. Now imagine if you have 1 million users trying to access this price. That is going to overload their database. Not only that, database is slow in terms of responding back and hence that's going to degrade the application performance. How can we solve this problem? We can solve this problem by adding a cache server. We know from our course that cache works faster than database, and hence we can now store the price of frequently purchased items in the cache server. Now when the user makes a request to the app server for the price and the description of a popular electronic device, the app server can first check if this information is available in the cache. It can then pull this information and relay the same to the end users. Thus, cache was able to reduce the latency and improve the performance of our application. Now you may wonder, why not store all the data in cache? Well, the answer is simple. Cache solves our problem, but it's an expensive memory. Hence, we should only store data that is frequently utilized in cache, or data that needs a lot of computational power and time. Now let's summarize what we have learned so far in this session. We learned cache is a short-term memory and can be used to store data that is frequently requested or to store data that can be pre-computed and served to end user with minimal latency. Cache reduces latency and also reduces the load on our database server. Cache works by storing frequently used data and thereby minimizing the load on database server. We also learned that L1 cache works at a higher speed compared to L2 cache. L2 cache is faster than L3 cache, and L3 cache is faster than dynamic RAM, and dynamic RAM is faster than hard disk. We also learned that cache in general is faster than database servers, but it is also equally expensive. Hence, it should be utilized accordingly. I hope you enjoyed this session. With that as a background, now I'll see you in the next session. Stay tuned. Bye. Hi there. I hope you enjoyed this session. If you liked this video, the full course is available on Udemy. Please take a look at that. And please don't forget to add your comments and your reviews so we can provide better content to you. I look forward to providing a lot of free courses to you. Stay tuned. Thank you.